Thank you very much for having me today. My name is Chris Vantine, Chief Technologist on the West Coast at Red Hat, and I've been with Red Hat for about 13 years. I work with customers up and down the coast in Silicon Valley and focusing on DevOps, containers, and Kubernetes, which this presentation is about, around security. So first off, Andy Grove talked about how only the paranoid survived back in the 90s, and this wasn't about security, but it's about strategic inflection points. When there's massive amounts of disruption going on around a company, maybe it's technology change or new companies entering the marketplace, and a company has to decide, do they stay the course with their strategy or do they shift and alter it and potentially thrive? And having a short feedback loop is certainly key to making the right decision. And we're seeing, a lot of disruption going on, and we're seeing that in all sorts of different industries, whether it's telco, finance, or the automobile industry. As we're seeing vehicles add more and more automation, there's this vision to have this fully autonomous experience. Not just with transportation, but across all different industries. And the ones who get there first are going to be the winners. And you can see in the transportation industry, here's the Tesla automobile factory. Automation is a key part in terms of building out the vehicles in the factories, but also automation is a key part in the terms of delivering security updates to the vehicles. For the first time that you buy a vehicle, you can get an improved vehicle 6, 12, 18 months down the road as they deliver software updates, whether it's security or new features to make it faster, 0 to 60, battery efficiency, or the new applications in the center console. And so automation is fundamentally transforming the whole business. And so most companies are having to make this transition. You take a look at a legacy company like Ford, they're very built on static and planned around execution. Right? They can mass produce vehicles across the globe. And then you have a more innovative company like Tesla that's focused around more innovation with a dynamic and policy-driven culture and process. And so companies are having to make that shift from the old to the new to become more innovative to stay relevant. And as a result, it's not just software as a part of this transition, but if you look under the cover with the disruptors, they have this shortened feedback loop that we talked about. The ability to have your pulse on the customer and deliver what they want quickly. And the ability to speed up innovation, the ability to leverage automation to deliver new updates rapidly to your infrastructure, to your customers. And so there's a lot of pressure on IT to not be the bottleneck for the business. And see, that's why you're seeing this shift to breaking down monolithic apps to microservices and speeding up the delivery with a cultural and process change with DevOps and a transition to self-serve multi-cloud infrastructure. So what does this mean from a security perspective? Right? The landscape is changing. It's getting harder and harder for the enterprise to keep it secure. There's geopolitical attacks and threats in terms of attacking the infrastructure. There's a dissolving security perimeter as applications are moved beyond just your own data center into a public cloud and becoming more and more distributed. And the infrastructure itself is evolving from a physical to software, whether it's compute, whether it's network or storage. And what does that mean from a security perspective? How do I address security updates when I go to a more software-defined world? And certainly as I go into a multi-cloud world and I allow my users to bring in their own device. So the traditional network-based defenses are simply not enough in this new world. And so that's where you're seeing this movement towards DevSecOps. Right? That's all about inserting security into the overall process of delivering new capabilities for the business. And it's based on reducing risk, lowering the costs, speeding up the delivery and reaction time when there are security issues. And it's based on automation, optimization, and continuous improvement. And so what does this look like? Well, it's inserting security first into the culture, right? Security first mindset. Prioritizing security from a business requirements perspective because your customers are trusting, and breaking that trust or losing that trust with your customers is lethal to your business. And inserting security into the process, not just inserting, but automating it, right? Becoming second nature in terms of addressing security, not just in production, but dev and test as well. And then, of course, leveraging technologies to enable more automation and simplification to address any security issues throughout the lifecycle. And so one of the key enablers to DevSecOps is containers. It's the ability to package up your application in a lightweight image with just the necessary dependencies and being able to share that as is across your environments, whether it's dev, test, production, physical, virtual, or private or public cloud. And that's because there's a standard runtime and a standard image format that allows that to be simplified, and the ability to run that as a container instance wherever your application may need to be. But what about managing at scale? Right? It's easy to run your container on your laptop as a developer, but what do I do when I have a data center, multiple data centers? Maybe 1,000+ instances that I now need to manage as my application has been decomposed into microservices, and I need the ability to have redundancy, secure infrastructure, and scalability. And so how do I manage that from a scheduling perspective? The life cycle, discovering those services, monitoring, scaling, having persistence for not just cloud native apps, but my existing apps, and logically orchestrating those applications that may consist of many microservices. And of course, the security as well across all my providers. And that's why Kubernetes is becoming very popular, the de facto standard when it comes to container orchestration. Whether it's bare metal, virtual, private, or public cloud, it becomes a consistent platform across all of your infrastructure. Not only that, but it's being viewed more and more as a security platform. Right? The ability to standardize your security processes and tooling across any provider, because I can install it on bare metal, across a virtual infrastructure, such as my OpenStack environment, or across a public cloud provider. And so today we're going to talk a little bit about Kubernetes and how to secure a large-scale infrastructure based on our experience with customers. So first off, key thing around Kubernetes, if you aren't familiar with it, is it brings automation to a large-scale container environment. The ability to define an end state declaratively, such as two web servers with a single database backend, and then it will go out and deploy that infrastructure for you and manage it for you. So in this example, I went ahead and deployed 2 web servers across multiple nodes. It found that resource and scheduled it for me intelligently. It then pulled the images and created the container instances on the nodes and front-ended it as a load balance service, so it distributed the load across those 2 nodes for me. I didn't have to worry about networking. I didn't have to worry about provisioning or configuring. It took care of that for me. As well as the database. It went ahead and provisioned the database, found an available resource, and front-ended that with a load balance service so that my web server could communicate with the database. So that's orchestration with Kubernetes. A second thing it brings around automating is making sure that that infrastructure is constantly in a good state. So it monitors my services. If there's an issue with one of the containers, it will actually go ahead, detect that, and replace it and schedule a replacement node. So I don't get that page at 2 a.m. and have to address that security issue. So in this case, there was a down web server and it scheduled a replacement for me automatically. Updated the network load balancer, etc. And then thirdly, it allows you to auto-scale your infrastructure. So if there's additional load out there, it will actually go ahead and provision additional, in this case, web servers to meet that load. As I set a limit of greater than 50%, it went ahead and created a third replica in this particular application. But what about securing that infrastructure? How do I automate this in a Kubernetes environment? Or what are some of the best practices I should follow when it comes to container images, builds, registry, the container host, as well as integrating security in my process? So first off, with container image security, One of the things about containers is it allows you to build out an image with just the necessary dependencies at the application runtime and as well as the OS. That allows me to separate my application from the underlying host and give me the freedom to have a different version than as on the host, so I can have multiple versions on a single host, providing multi-tenancy. But it also allows me to reduce the footprint. From a security perspective, if there's less in that image, there's less to attack. And thirdly, it gives me the freedom to build that image once and deploy anywhere. So my testers and my operations teams are not rebuilding and introducing security issues or drift, which slows me down. And from a container image perspective, your developers are now potentially, if they're developing in Java, typically delivering a jar file. One of the big shifts as you move to a containerized environment is now they're probably delivering to you a container image. And what's inside this image? It's no longer just a jar file, right? It's the language runtimes and the OS dependencies. Right? So from a security perspective, now who owns the security tracking the issues and updating? Is it the developer because they're delivering it? Right? Or is there a model where you could actually continue having separation of ownership with your application runtime team and your system administration OS team? Right? And we'll talk about that. But first, one of the best practices around containers is to treat containers as immutable. And what does that mean? That means don't store your configuration information, the state, in the image itself. Extract that out. So that means environment variables, configuration files, etc. Anything that's unique to the image should not be in the image. Right? When the developer delivers that image, it should just contain its code, the application runtime, and the OS dependencies. And so in Kubernetes, how do you insert your configurations? Well, there's some objects in Kubernetes. One's called a config map, the other one's a secret. It allows you to import a configuration file, for example, for JBoss, or a configuration setting for your database, such as username, password, and that could be stored in a secret, which is encrypted. Right? And then when Kubernetes deploys that web or database, and it needs those configurations that have been defined, it inserts them on the fly. Right? It could be mounted into a file in that image. It could be set in an environment variable, and then your application could read those in. But the key is I'm not storing that state in there. So from a security perspective, I'm not storing username, passwords at rest in those images. Also, the data. You don't want to keep the data that's unique to that application inside the image as well. Instead, store that into traditional data service. So that could be a service that's running on top of your Kubernetes cluster or remotely in a cloud service on a public provider even. Also, Kubernetes allows you to provision persistent volumes so that you could store your state on that as well. In terms of best practice on the image, once you do build that image, you want to sign that image. And in Kubernetes, before you launch a container instance from an image, you can validate that image is from a known trusted source based on its signature. Right? So that's a way to ensure that you're not having rogue images running into your secure Kubernetes cluster. What about container builds? How do I go about building these images? So in a DevOps environment, we want everybody speaking the same language. And that's one of the great benefits around containers. It brings everybody together because they're all defining their layers that they own with the same syntax and same language. In this case, the Docker build file. Right? That build file is consistent across the OS layer, the application layer, runtime, as well as the application itself. So I have my developer, my application owner, runtime, and then my OS builder, maintainer using the same definition. And within a container image, I can layer and inherit what my other team members have done. So if I have an application I'm developing in Java, I can just select the JBoss middleware image, which was built on top of the standard Linux base image. And those individuals are maintaining those layers, and they're responsible for updating with new updates to address security issues or bug fixes. And so the developer is not taking on added responsibility. Another thing I can do is once that application is in production, I can trigger automated rebuilds. So if I have an application that depends on my JBoss middleware image, which is built on RHEL 7 Linux, if I update the RHEL 7 Linux image as a sysadmin with a new security update, I can set up an automated process that detects if an image gets updated in my registry that I depend on to trigger an automated rebuild. And so this is how you can do a cascading rebuild, is if the RHEL 7 image updated and my middleware layer depended on, I could rebuild all my middleware images. And likewise, if I had my corporate application in Java that depended on those and it detected a change, it could trigger an automated rebuild as well. And so my developers don't have to worry about it. It's just automatically updated whenever there's a security issue in the middleware or the OS layer. So some of the best practices around build files. On the left is an example of a well-written, simple build file. One is you want to treat the build file as a blueprint, right? So you have a recipe for how to build every one of your images. Right? This allows you to go back in time. When that owner moves to another responsibility, you can still recreate it to address issues that come down the road. Also, you want to version control it, store it in Git, for example. Don't log into a container instance, make changes, and then save it to an image, because then you don't have a build file to recreate that. Be explicit with versions in the build file. Don't specify latest, because latest today is not latest tomorrow. And then also list the full registry name that you're pulling from. So be fully qualified. So it's very explicit of where that, no matter what environment you're in. And as you pull down images, especially from Docker Hub, the default is root. And so you don't want to run root images, certainly not in your production environment. Specify the user that the image is going to run as, and you can do that in the build file, as exampled on the left side there. And then just remember, every time you specify run in the build file, it creates a new layer, so that causes some inefficiencies. What about the container registry security? So we did a scan of the public Docker Hub and we found 64% of the images out there have a high or medium priority security issue. And so you need to be careful about where you're pulling images from into an enterprise. And so one of the things I see most enterprises, the first step they take from an operations perspective is they set up a private registry behind their firewall that they control. They know who is pushing. They have a full audit trail of those images. And 12, 18 months down the road, they have all the components because they're putting all the dependencies in there too. So make sure that all the images that you need for your environment are stored in your private registry, because then you can own the life cycle. You don't have to worry about a third party removing stale or old images down the road, and then in 12 months you need that image and it's not there. Container host security. So an important part of ensuring the ability and the flexibility to move your image from dev test into production or across physical, virtual, private, public cloud is consistency at the OS layer. Because not only from a runtime perspective, but also from a security perspective. Containers are Linux, and there are several key capabilities in a Linux host that ensure a secure environment. And not all of these are turned on by default. So it's a best practice to make sure you're leveraging these as much as possible for your particular environment to ensure a secure container runtime. And we'll talk about those. First off, C groups. C groups provides quality of service. That allows a container instance, which is just a Linux process. So if you log into a Linux system and you look at your container instances, it's the same as a Linux process. All the tools work, etc. And one of the things you want to do is provide multi-tenancy, and C groups enables that because it provides quality of service and guarantees around CPU, memory, network, and storage I/O. So you don't have that noisy neighbor problem, or you don't have a rogue application causing a security issue. If you're attacked by a denial of service, for example, you can limit the resources that they consume. Also, namespaces are a big part of security as well. You have network namespaces providing logical separation of the networking amongst the containers. And then also you have user namespaces, which ensures, for example, that the root user in a container is not the same as being root at the host or the other containers on that host. And that's important in case there's a security breach in one of your containers that you're running, and so it doesn't compromise the entire system. Right? Without user namespaces enabled, that could be potentially a threat unless you're addressing that via other mechanisms, such as SELinux. Right? SELinux is typically turned off by default by many enterprises, but in a container environment, it's very important to enable that and to configure it so that that process that's running the container instance only has access to what's explicitly stated in the SELinux policy. Right, that's important because if there is a security issue or a breach, it prevents what that process can have access to. Also, setcomp and Linux capabilities. Setcomp filters, there's hundreds of system calls to the kernel. A container instance doesn't need potentially access to all those. So if you know that you can reduce that filter or put a filter in place and reduce the number of calls it has access to, that just avoids a potential issue down the road when there's a known vulnerability, right? And you don't have to worry about that because that container instance doesn't have access to that. Linux capabilities, if you do run as root a container instance, this allows you to slim down the privileges and capabilities of a root user. So some best practices kind of reduce what a process has access to. Also, read-only mounts. So when a container instance is mounting a file system, you want to mount as read-only if that's all you need. And for example, /sys, /procsys, etc., those file systems need to be read-only. Right? And that allows you to limit a rogue process from altering the settings and causing a security issue. So, in regards to best practices around container hosts, don't run as root. If you must, limit Linux capabilities, limit SSH access to your container instances, use namespaces, define resource quotas, enable logging, right? So you can do some root cause analysis when there are breaches. Also apply security around not just to the container instance, but to the host as well, as you are doing today. Apply security context, so Kubernetes has the ability to apply setcomp filters across your cluster, and then run production unprivileged containers as read-only as much as possible. What about integrating security into your CI process? So one of the things with continuous integrations and container builds is that ideally you want to get to a state that's repeatable. So every time you build that image, that same version, it ends with the same output. And why is that important? Well, security breaches aren't just about attacking source code. It's also about folks attacking build environments and inserting different compilers that insert a vulnerability. And that is important to address, and you can address it in your container build environment by doing a few things. One is you have a standard build image. And this build image is a containerized image that has all the build tools you need, for example, for your Java application. And what it will do is take the source code, build your tool, your application in that build image, and then output another container image with just the resulting binaries, the application runtime dependencies, and the OS dependencies. Right? It doesn't put the build environment. But what I've done with that build image is I version controlled it. So now when I need to reproduce version 1 of my application, I know that I use version 1 of the build environment as well that went along with that. Right? So I'm reducing the drift and increasing the reproducibility, and I'm ensuring that someone didn't inject, or I can detect if someone's injecting something into my build environment with a higher degree of confidence. Right, so reproducible builds. Also, when it comes to builds, what's inside the container matters. From left to right, we have a C, Java, Node.js, Perl PHP application. And those rectangles indicate components were pulled in during the build process for those applications. For example, the JRE was pulled in when I built my Java app. It also pulled in Bash and glibc. Right? So I have my application runtime and my OS dependencies that were pulled in. And the little triangle indicates how many security notifications for those components that have been released. And this information is a little bit stale, so those numbers are even higher today for those components. In this case, the RHEL 7 lifecycle. So 66 security notifications for the JRE. I need to be concerned not only where I'm getting those images from and what's in them, but also over time, I need a process to be scanning and addressing those issues. And so best practice is there's an example Jenkins build pipeline that your developers are using, potentially, to build their applications and to push it through a pipeline. You want to insert potentially a security phase as a part of that pipeline. And that means all your container images that are being built will then get scanned for potentially security vulnerabilities or if it conforms with your security policy. There are many different tools out there, third-party tools. There's upstream open source tool called OpenScamp, which can be used to scan your images. It also scans VMs and physical systems. But that allows you to scan for known vulnerabilities based on RPM versions. And it also allows you to find a security policy. And there's a lot of predefined policies just for general Linux, PCI, a variety of government and healthcare standards. And you run this tool, it flags any known vulnerabilities, and it produces Ansible scripts to remediate the issue in that container instance or virtual machine. And then it generates a report, so you have an audit trail from a security perspective. So whether it's OpenScamp or another tool, the key message is to make sure you're inserting it into your CI/CD process. Continuous delivery. So one of the fundamental changes as you move to from a monolithic environment to a microservice environment is that you're moving from deploying applications every 6 to 9 months to a matter of minutes or hours, potentially, in your environment. Right? So that's a huge shift. And when it comes to security issues, I'm no longer logging into my production environment and patching the existing infrastructure. Instead, you're always going back to the beginning of the pipeline and creating version N+1 to address this security issue. The reason you do that is you're going to get higher quality by always pushing all changes through your testing process. And so that will ensure that you have a higher quality And the reason you can do that now is because you can deploy a new version in a matter of minutes or hours. Right? In the old way that was manually done, it took months or weeks to push out a new version. So now you can leverage this highly automated pipeline to improve security and quality. And so when it comes to a security issue in production, you go back to development, you create that container image once, push it into test it, push it into production as is. No rebuilding, no reconfiguring. And so how do you deploy at scale? We talked about deploying in minutes or hours. How do I do that? I need to leverage automation. And Kubernetes allows you to automate the rollout of security updates or application updates at scale. And there's different built-in deployment strategies. One's called recreate, rolling updates, blue-green deployment, canary with A/B testing is another style. So let's go through those. So first off, recreate with downtime. So this is an application. We have version 1 out in production. It's not a critical application. It's okay to have downtime. This is very simple and straightforward. I have a security issue. I bring down the cluster after I put the new version through CI testing, and then I recreate the cluster with version 1.2. Right? So there was a period of time it was down, but I didn't have to really communicate with my developers. I didn't have to make sure that there was backward compatibility. Right? I didn't have to worry about schema incompatibilities, etc. It was pretty simple. But the real world is, I typically, in a global 24/7 world, not all my services can afford to have downtime. And so how do I address those? Well, I may want to use a rolling update. So this is a rolling update with 0 downtime. I have version 1 out in production. There's a security issue. I patch it in 1.2. I put it through testing. And then gradually I roll it out one by one into my existing environment. And you can see one of the things that Kubernetes will do is you can have a health check. So I don't add that new version into rotation until, for example, it's getting communication from the database. Once it does, I can update the load balancer and then deploy it to the entire environment to 100%. The cons are with this model is that I need to have backward compatibility. I have 2 versions in production at the same time. There's also some resource overhead, slightly. And then the con is, or the pros are, I have 0 downtime, right, with this model. Don't have to worry about scheduling downtime. I can just gradually roll it out, and I can also roll back at any time in this process. So if there's an issue. Another alternative is blue-green deployment. Slightly different in that here I have a blue environment with my existing version. There's a security issue. I need to go ahead and develop version 1.2, but instead of deploying into my existing environment, I'm going to create a new environment. So with Kubernetes, I can create logical mirrors of my production environment, whether it's on my laptop or in my full-blown data center. And so this allows me to experiment and try things out and have a high degree of confidence that there's no drift change between environments. And so here, I have version 1.2 in my green environment, put it through testing, and then I can just update the load balancer to redirect the traffic to the green environment. If there was an issue, I can roll back because this is really safe as well because there were no changes made to the blue environment at all. So I'm going to go back to existing state as it was. So low risk, no downtime, and production-like testing, as well as a rollback. Now, the con is you need extra resources. It can be the same physical infrastructure. It's just some logically additional resources on top of that that are going to be consumed, depending on whether I've scaled down my blue environment before I do this switch or not. One of the other things with security updates is I want to be able to allow my developers to experiment, try them out in production, as much as possible to get a real world impact. And so one of the things with Kubernetes I can do is manage certainly microservices. And one of the key things around this is, only a third of the ideas improve the metrics that are designed to improve. And that's exactly what this addresses, is having that continuous feedback loop. So if I deploy a security patch, I want immediate feedback if that's causing an issue, so I can shift direction. And so you can do that with A/B testing using a canary deployment. On the left, I have my existing app, and on my B, I put a security update, but I also added in a change to my recommendation engine. You can see the products it's recommending are slightly different on the right side. And so I want to make sure that my business is not impacted negatively by this new version. And so in my existing version A, I get a 25% click-through rate. All my traffic is going to it. There's a security issue. I added that new recommendation engine at the same time. And this is version B. I noticed that the click-through rate actually improved. So that's great. And so I'm going to go 100% all in to that version. However, if I had seen a decline in the conversion rate, that might give me pause for that rollout and do a further investigation. And so I can revert back to version A and do a root cause analysis of that. And so that's A/B testing with a canary deployment on Kubernetes. So one of the key things with these deployment strategies is today, perhaps your developers are doing these types of strategies, but they're writing and maintaining the scripts on their own, right? And so that's more time spent doing things that are not about new features for the business. And finally, securing your environment. We'll talk about network monitoring, storage, API, and federated clusters. First off, network security. So some of the things that Kubernetes provides around security is certainly around network isolation. The ability to have multi-environments or multi-tenancy. By multi-environments, it leverages network namespaces to be able to carve up separate logical environments that are isolated from a network perspective on the same physical infrastructure. So it layers on the networking on top of your physical layer. And that allows me to do things like have dev tests in production all on the same infrastructure. And I can have multiple production environments, as we saw in the Bluegreen deployment. Secondly, multi-tenancy. I can have all my business units sharing the same infrastructure. They don't have to have their own dedicated, so much more efficient because I'm able to provide a secure networking environment. But there are cases when you need to open up things between logical environments, and so there's network policy. Right? This allows you to define a whitelist of communication. For example, I want to allow project B to be able to have access to A or vice versa. And so I could actually define a policy in Kubernetes to explicitly have fine-grained control over the communication access from one pod to another or one environment to another. Right. Also in the network security, you have your traditional physical network model. Typically, you have your DMZ, you have zone, another zone called your internal, and a third zone, your database. And typically, the traffic is highly regulated in terms of one zone to another as it flows, and it's typically one way as well, except for the DMZ. In the Kubernetes networking model, it's a flat model where everybody can communicate with everybody. That's the assumption. And it's flat network as well. So how do you set up a cluster in this type of environment with your old existing structure? And so what we're seeing customers do is typically if they're setting up Kubernetes to manage the application or the database zones, they'll set up potentially two different clusters, one for the application zone and two, another cluster for the database zone. Right? And then they place their routers and egress in those zones. And so applications C and D, for example, in your database, they have in and outbound traffic through that. Likewise, your applications A and B, they run in that cluster, and their traffic goes through the egress in the routers in zone A. You could also have a single Kubernetes cluster that spans across both zones. For example, you have applications A, B, C, and D. However, their inbound and outbound routing is for A and B is through the router and egress in zone A, and C and D, it would go through the router and egress in zone B. And then lastly, another model is if you want to make sure your applications for a particular security zone, network zone, are limited to only nodes in that zone. And so here you have a single Kubernetes cluster, but you can use labels and label your physical nodes. And then the scheduler, as you deploy that application, it could have a selector that says, hey, this is application A or B. I only run on hosts that are mapped and bound to network zone A. And so this is less efficient because, for example, the green nodes, physical nodes, are only going to run applications A and B. But may give you a peace of mind knowing that those applications are totally separated in terms of what nodes they're running on. Monitoring and logging. So a big shift as you move over to a containerized environment, and you need to monitor more, you need to log more. And one of the differences, today you're probably monitoring at the host level and the application level. In a Kubernetes environment, you now have to have some metrics around your container and your Kubernetes management environment. Also, a shift from monolithic to microservices means you need some tools around distributed applications, right? So distributed tracing tools are becoming more and more necessary to identify security issues, bottlenecks, et cetera, in your application. And so here's just some of the metrics in the middle column, and then the tooling from a Kubernetes perspective that you may want to take a look at. It's included, or third-party toolings as well, other projects. So Istio, Jaeger Tracing are popular from Uber and Lyft. And Prometheus and Grafana providing real-time monitoring and a dashboard. And then also Kubernetes probes and state metrics, and the C-Advisor as well as the node exporter provide some of the raw metrics at the host, container, and Kubernetes level. And you're able to aggregate these, search them with Elasticsearch when you're debugging or trying to do a root cause analysis of some security issue. These are some of the metrics and tools you may want to have access to. And I mentioned Elasticsearch and Kibana. Those are the logging, searching tools that you may want to take a look at within Kubernetes. Storage security. So you can define storage security around defining storage quotas, so you can limit what your developers can consume or the applications consume, so you don't have a problem where one application is over-consuming from a security perspective and creating a poor quality of service. Then you also can define different storage classes for your persistent volumes. So you can define a class specific to a particular application, so you can limit what that application can actually have access to. Also, API and platform access. This is really important. If you look in the newspaper, some of the key security vulnerabilities or breaches for Kubernetes to date, look at Tesla, Weight Watchers, etc. They have been Kubernetes environments that have set up out of the box without applying any additional security settings. And they typically have gotten to the admin console and then have access to whatever data that exposes. And so you want to make sure that you're setting up authorization and authentication for your Kubernetes cluster, limiting the capabilities that a user has, and front-ending it, the API with an API gateway that limits from a security perspective, also can have quality of service as well. and the billing if you'd like to. And lastly, federation. So from a security perspective, there's a movement towards having many clusters under a single API management in Kubernetes. There's a Kubernetes project. From a security perspective, you could have different clusters that meet different security standards and then route applications to that particular cluster. So what's next? As we look forward, running out of time here, but Istio, from a security perspective, allows you to do key rotation between service to service. Also allows you to leverage the proxy, which blocks all traffic by default outbound. Operators allows you to automate the management of your applications, whether it's a third-party app or an internally developed app, and bring a user experience that's on par with a public cloud service. So that means auto provisioning, auto HA, all the things you would manually have to do from a runbook perspective, automate those, including security.
I'm afraid we have to wrap it up.
So that's it, and I want to thank you for attending today's session. If you have any questions, here's my email and Twitter, LinkedIn. Find me there, and I'll also be outside if you have any questions. Thank you so much.
Thank you, Chris.